Thank you very much. Our next presenters are from Sensirion Company, Marco Gisel and Antonio Rubino. Their topic is about the air. Get the full air quality picture with a single sensor solution. Both of them are product manager at the company. These talks will illustrate the impact of the most relevant air quality parameters and how it can be measured. Marco, let me ask you a question. How good are humans at perceiving the air quality at their surroundings?
Great question. So first, thank you so much for having us today. We are very excited about today's webinar. How well are humans at perceiving indoor air quality? Well, it depends. There are some aspects of indoor air quality that we perceive very well. One example would be relative humidity. You get dry skin if it's very dry, and you would also feel if it's very humid. But then there are other aspects to indoor air quality that we perceive decent, like volatile organic compounds. Some smells we perceive very well, others not so much. And then there are aspects to indoor air quality that we don't perceive at all. And I think a very good example here would be carbon dioxide or CO2. With that, welcome to today's webinar. Who are we? My name is Marco Gisel. I'm a business development manager with a passion for clean indoor air. And today here with me is Antonio Rubio, who is a product manager for our sensor environmental node. What will we cover today? First, we'll talk about why we should care about indoor air quality, and then second, what the pollutants are that we encounter on a daily basis. Part number 3, I will hand over to Antonio for that, will be about our environmental node, the SEN5X. Part number 4, we will get very specific on how you can get started with our air quality sensors. Before we start with the actual presentation, few words about our company. Sensirion is headquartered in Switzerland and was founded roughly 25 years ago. Since then, we grew a lot. We are now more than 1,000 full-time employees. We have a global presence with sales subsidiaries, but also operation sites in Europe, Asia, and the US. We sell to many different markets. Some examples are being displayed here. Medical, automotive, but then also consumer-grade products are among our customers. We are one of the global leaders of air quality sensors. We sell them to air treatment devices, such as air purifiers, but also to indoor air quality monitors and to HVAC system. So HVAC stands for heating, ventilation, and air conditioning. I already mentioned that we are a leading manufacturer of air quality sensors, or environmental sensors, how we call them, but we are also a leading player in the field of flow sensors. We sense liquid flow, but also gas flow, and then also differential pressure. With that, let me get started. Why should we care about indoor air quality in the first place? And I think a very prominent example that most people associate with indoor air quality these days is COVID. A few months ago, a professor from the Imperial College London said that we do not build up herd immunity through Omicron to the extent that we were hoping. We don't produce as much antibodies as we hoped. Now, what does that have to do with clean indoor air? It turns out that almost all COVID infections happen indoor, and most of them are transmitted via so-called airborne particles. So these are aerosols, just very small water droplets that contain the COVID virus. Turns out that masks do help against this form of COVID transmission, but it's not a full solution. We see more and more viral mutations, so the vaccine is also only partially helpful, and there's a huge suffering from long COVID around the globe. One of the most effective ways to tackle COVID is to control our indoor air quality and thereby ensuring that airborne transmission is reduced. And because of COVID, the mass media is full of articles or television shows are full of reports on the importance of clean indoor air. Most of them associated with COVID infection risk, but indoor air quality is much more than that. It's important to realize that there are also other chronic diseases associated with bad indoor air quality and many deaths that can be accounted for bad indoor air quality. Governments around the globe noticed that this is a very important topic. They gave out recommendations, but not just that. They also invest heavily into clean indoor air quality. We see that in the US, we see it in Europe, but also in Asia. Typically, they encourage public places to display air quality in some form or another, to renew ventilation systems, or to add air purification systems to public places. The maybe most prominent example of that is the Clean Air in Buildings Challenge from the US. So the White House earlier this year declared that some of the ARPA, that is the American Rescue Plan funding, can be used to mitigate or to improve indoor air quality. And these funds account for roughly $470 billion US. So that's a gigantic sum. And what this Clean Air in Buildings Challenge does, it's a call to action for building owners and operators with 4 very easy steps. Step number 1, create an action plan. So understand your air quality or the status quo. Step number 2, increase or optimize air ventilation. Step number 3, add air filtration. And then 4, engage your community. Let's take a closer look at step number 2 and step number 3. Optimize air ventilation. Why would you want to do that? Turns out that there are aerosols very stable in the air containing COVID viruses. We can dilute them by bringing in fresh outdoor air and replacing stale indoor air. There are scientific studies that show that up to 80% of COVID infections can be prevented simply by having high ventilation rates. Air filtration, very similar picture. We can filter out aerosols that are stable in the air. Also, their scientific studies show that up to 80% of COVID cases or COVID infections can be prevented by having proper air filtration, specifically MERV 13 or higher. These are great news. All we need to do is run the ventilation at full speed all the time and add air purification. Unfortunately, it's not that easy. Clean indoor air comes at a cost, and these costs are CO2 emissions. Turns out that HVAC, heating, ventilation, air conditioning systems account for more than 6% of CO2 emissions globally. To put that into perspective, aviation, that would be passenger and freight, accounts for only 2% of global CO2 emissions. So, heating, ventilation, AC, 3 times worse. We need to balance these 2 things. On the one hand, we need to have healthy indoor air that makes sure that people don't get infected with COVID. On the other hand, we need to be energy efficient. To have both, we need smart ventilation systems that make good informed decisions, and to do so, our air quality sensors are necessary. CO2 sensors help our HVAC customers to use so-called demand-controlled ventilation, and then our particulate matter VOC sensors help the optimization of air purifying devices. I hope I was able to convince you that air quality is a very relevant topic, and with that I would like to talk about pollutants that we typically encounter indoors. These are the 5 ones. I will talk about them in a minute, that we typically see indoors with a source that is actually indoors. But then it's also important to understand that indoor air quality often depends on outdoor air quality. because whenever you open a window, you let outer air pollutants come in, such as PM2.5 and NOx. The pollutant that maybe got most attention throughout the COVID crisis is carbon dioxide. Why is that? We exhale CO2. In confined indoor air spaces, CO2 can accumulate over time, and high CO2 concentration has an impact on our cognitive performance and on our well-being. But it's not just that. It's also a good proxy for aerosols that we exhale, so tiny water droplets. That could potentially include COVID viruses. So by measuring CO2, you can somehow get a proxy for COVID infection risks. How is it measured? With so-called optical non-dispersive infrared sensors. CO2 is chemically inert. We need an optical source to measure it. And there are two different types of NDIR sensor. The one is transmissive or optical detection. The other one is acoustic detection. Sensirion has both of these technologies in our lineup. Our newest generation, the SCD4X, is acoustic type. It's the smallest optical CO2 sensor on the globe at the time of recording. It is truly selective to CO2 and it's reflow solderable. So thus making it easier to integrate and manufacture. Going on to the next pollutant, one that is maybe most prominent, that is PM2.5, particulate matter, or also smog. These are very tiny particles. To get a sense of how small they are much smaller than human hairs and fine sand beach that we know. The smaller the particles, the more dangerous, because they can penetrate deeper into our lungs and into our blood system. And they are responsible for many deaths globally. How do you measure that? You measure that via so-called laser light scattering. The way it works, you have a laser that shines on an airflow, and whenever there's a tiny particle, light is gathered, that is detected by a dedicated detector. Our solution to that, the SPS 30, offers long-term stability. That would be 10 years plus. It comes with an algorithm that allows to differentiate between particle sizes, and it is also very performant across different aerosols. Pollutant number 3, that is somehow more complicated, are so-called volatile organic compounds. So that is a class of molecules that is in the gas phase at room temperature. And sources are very different. If you use a deodorant or a perfume that smells nice, that's a VOC. If you drink wine, ethanol evaporates, that's a VOC. But then there are also very harmful VOCs. And these are very different to distinguish. That's why they are oftentimes measured as one entity called total VOC, total volatile organic compound. NOx, so nitrogen oxides. Typically, this class of pollutant originates from a fire or a burning process. So indoor sources could be cigarette smoking or a gas cooking stove, but then outdoor sources would be traffic. The way we measure, or also the industry standard to measure these two types of pollutants, are with so-called metal oxide sensors. The way they work is to have a sensitive metal oxide layer that is heated up to a very high temperature, several hundred degrees Celsius. When a molecule hits the selective layer, it gets either oxidized or reduced, and that changes the resistivity of the material. Our solution, the SGP4X, offers two independent outputs, VOC on the one hand, NOx on the other hand. It comes with superior reliability through lifetimes and with algorithms that make sure that the user experience is great. Moving on to the maybe best known air quality parameter, that would be relative humidity and temperature. And that's a classical example of something that we perceive very well. So these two things, on the one hand, have an impact on our immediate well-being and cognitive performance, but on the other hand, they can also be correlated with chronic problems. As an example, if the relative humidity is too high, mold will grow, and that can lead to chronic respiratory illnesses, diseases. The way to measure that is with a capacitive sensor. So you would have, let's say, selective or a material that where basically water molecules can diffuse inside and thereby change the capacitance of this layer. Sensirion has been the market and technology leader for this type of sensor for 20 years plus. We offer the lowest power consumption and many specialized different product variants. Going on to the last slide, from my side, formaldehyde has been a huge topic in Asia, specifically China. Technically speaking, it's just one of many VOCs, but there's a high attention on formaldehyde for two reasons. One, it is very dangerous, it's associated with cancer, and two, it occurs quite frequently, also at high concentration in indoor air spaces. Typical sources are new furnitures, especially the wooden furnitures. The way to measure formaldehyde selectively is with electrochemical sensors. Basically, they react, or there's a cathode that reacts with the formaldehyde and thereby produces a current that is proportional to the formaldehyde concentration. Our formaldehyde sensor, the SFA30, offers the lowest cross-sensitivity to VOCs. It comes with an advanced relative humidity compensation, and it also has a very long lifetime of up to 6 years. With that, I conclude the second part and hand over to my colleague Antonio.
Thanks, Marco. So let's move more into the application and our solution with our sensor node. So let's take as an example an application requiring the measurement of PM, VOC, NOx, humidity and temperature. As explained by Marco, these are relevant parameters to monitor air quality. In this case, we need up to 5 sensors, and in order to implement the applications, we need to connect them with cables, electronic boards, and so on. So looking at the final application, it looks like how it's showing in the slides. So it requires a big dead volume, and the final result will be a complex interface. The implementation requires high integration effort. Several iterations will be required to get the final product, and also if the process is successful, the final application will require considerable space, and the supply chain will be really complex, and everything results in long go-to-market time. Sensirion is happy to introduce our solution to this problem with SEN5X. It's a combo module, really compact and easy to design in. So your application results in a robust supply chain, and everything is optimized to get the best for each single sensor. So you can measure each single parameters in the best way. So SEN5X will have a 5 voltage supply voltage, and includes an R2C interface and an operating temperature from -10 to 50 degrees Celsius, and a lifetime of more than 10 years thanks to the sheet flow technology. For PM, we have the patent airflow design, and there are different beams, and the sensor can measure PM1, PM2.5, PM4, and PM10 with best precision at PM2.5. For temperature, the module includes temperature acceleration and compensation engines, and with an accuracy for humidity of 4.5% and a temperature accuracy of 0.45 degrees Celsius. For the VOC and NOx, we all know it's really difficult to deal with the output of the MOX sensors. That's why Sensirion has implemented an index concept. For both VOC and NOx, there is an index with a range from 0 to 500. And the sensor, together with the algorithm, identifies an average, a background, giving a value of 100 for VOC and 1 for NOx. This is because we always have a background for VOC, while for NOx in normal condition we don't have presence of NOx. The idea of the index is to identify trends. So if there is a variation, the index increases. If there is a variation towards better air quality, the index will show lower value. And ideally, this is really easy to implement and can be used as a part of a closed system. For example, for an air purifier, this can be used to understand when and for how long and for with which power the purification needs to be activated. Regarding humidity and temperature, Sensirion features the STAR engine, Sensirion Temperature Acceleration Routine engine, to accelerate the reading of temperature. And thanks to the algorithm, the time the end user will have the value can be reduced by 2-3 times. This acceleration is tunable with 3 presets: low, medium, and high accurate acceleration. And also accuracy is reached by compensation, so a value of plus minus 4.5% in humidity and 0.45 degrees in temperature accuracy can be reached also with the end product. So let's move now to the start, to how to get started. Everything starts with the evaluation. So customer can start the journey ordering our evaluation kit, the SEC Sen5X. That includes everything you need to start the evaluation. So the module and cables to connect directly with the PC. The module is more than 5 sensors put together, since there is a single interface and all the algorithms are already implemented and the sensors are calibrated. So there is an advantage also from the hardware side, because all the sensors sit in the right position with the optimized flow and all the compensation to work in the perfect way together. Typical examples where to find application of Sen5X are indoor quality monitors. Due to the compactness, the end product can be really small, compact, and smart, measuring all the relevant parameters. And as I mentioned also before, typical applications are air purifiers, where sensors are used to quantify and trigger the actions of the purification. So to summarize, Marco talked about what's important, how measure air quality, what are the relevant parameters, and we also show nice solutions to measure all of them together in a combo with relevant application for air quality monitors and air purifiers. Thanks for your attention. Here are a list of links and documents for your reference.